Hi, Jim Rodgers again, and I'm going to be dealing with some questions today. The questions have been sort of like, why do tools catch? How much pressure do I need to apply where? So I'm going to take this through in multiple parts. I'm going to deal with gouges first. Then I'm going to deal with double-edged devices like skews and parting tools second. And for the third part, we'll deal with scrapers, which are sort of like the same, but not. So we'll deal with it in three sections. So one of the things I know when we get a catch, it normally scares everybody that it's something that's really bad happened. It really is not. What it really is the tool taking a bite of wood that's not something you expected. It should be larger than you expected. Or maybe it jerks the tool in your hand in a way that you hadn't anticipated, and so on. I'm setting up on the robust Scout lathe here, and I'm setting up with what's called a safe drive center. It's like a spur drive with no teeth. So when I turn the lathe on, depending on how tight I tighten the tailstock, I can literally grab and stop this piece of wood. So when I get a catch here, nothing's going to go flying. The wood will literally just stop turning. And I can control how much force that requires by simply how tight I tighten the tailstock. So I set it so that with a little bit of pressure I can grab it. So we know that tools cut. They have several components to the cut. Number one, we have to have an edge that fits against the wood. We have to have some way to support that edge so that it goes where we want it to. And the reason why block planes, for instance, don't get catches is the fact that that edge is totally supported by what we call the sole. So if I put this block plane on here and actually run the lathe if I want, I guess I could. I'm actually cutting wood with that. And I didn't get any catches. And the reason I didn't is that edge was completely supported at all times. So we don't have that problem with some of these flat woodworking tools like a plane. Could I do it with a chisel? Well, the chisel has a bevel, much like our wood turning tools. And if I put that bevel against the wood properly, I have a supported cut. Tool rest, bevel. Let's see if it'll work. On the tool rest, now I don't quite know where the bevel is, so I'm going to start no bevel. I'm going to raise the handle until I get a cut. Ooh, I got a catch. Let's take a look at that. Did you hear it? And there you can see the remnants of it. What happened? I'm cutting along with that bevel support, and I raised the handle too far. The bevel came off of the wood. The edge then was able to go down into the fibers and cut deeper than what I could control. What it did is it dug in. It pulled my handle up off the tool rest. Not a very good bevel, but it could do it. So that's the catch that everybody's asking me about. Looks terrible. And for us, we typically start with what's called a spindle roughing gouge. It has a bevel. I lay it on the tool rest. And the way we teach our students is we turn the lathe on. I'll move my cart out of the way a little bit because I want to stand a little bit more to the left. And I'm going to raise the handle until that bevel is touching and the edge is engaged. Right there. I'll get a nice cut. Stopped a couple times. What? It ran into these protrusions. Well, there's only one left now, where it was cutting too deep. A little more pressure and that would have been okay, but let's do it one more time. Now, not a bad surface. I can make it better with the same tool. I was going in straight in like we were taught in our Wood Turning 101 class. But I also know that if I skewed the tool to an angle, I can get an even cleaner surface. Let me show you and then let me explain. I'm going to go from the left. I'm going to find that bevel, except I have the handle over at an angle. Came halfway. And I don't know if you can see it, but from here to here, the surface is significantly smoother than this area here. What's the difference? It comes back to all these forces that go on when you're cutting. Somebody asked the question the other day, how much pressure? And I started thinking about pressure where? I have pressure downward on the tool rest. That's important. If the tool comes up off that rest, I have no control. I have pressure of putting this bevel, this part behind the cutting edge, against the wood to keep it in touch. Piece of irregular wood bouncing around a lot, that's kind of difficult to do. And then I have the pressure of how much inward force I apply. How much am I trying to take away those wood fibers by getting underneath and reeving them free. Now that's not much pressure. But to get a clean cut, it's not necessary to have a lot of pressure, because one of the pressure aspects that's going on here is the machine with its 2 horsepower motor here is doing some of that pressure of bringing the wood towards the cutting edge. So downward pressure here, enough to keep it on the tool rest. Inward pressure, enough to keep that bevel against the wood. And the third one is the force cutting this direction is pretty much managed by the motor on this machine, bringing the wood to the edge rather than me having to push it in. And I wish you could see the difference between these two surfaces. Well, why does skewing it at an angle create a better cut, a more sheer cut than here? Well, let me see if I can illustrate that with a drawing. I hope my drawing is clear enough that you can see it. Let me go here to the board. When I come straight in like this, the blue is the shape of the edge that I'm working with. But when I take that tool and tilt it to the angle, that edge towards the wood appears to be much narrower, much smaller. So the engagement here and here are different. This requires less force to reeve the fibers apart than this does. Or for the same force, it reeves them apart more smoothly. So anytime we skew a tool around, we get that effect. I can come in here with my bowl gouge straight on, or I could come in with my bowl gouge at an angle, changing that apparent angle to the wood. Now with gouges, there's other things going on too. We have a lot of cutting surfaces here, each one of which has its own value. But catches are something that we need to manage by managing the bevel and all those pressures. Now I could rough this out with my bowl gouge. I could rough it out by going straight in. And I have a very small cutting area here, and as I move along, it might create a little bit of rippling on the surface. I could come in by using the longer side, thus bridging over a longer distance and making it smoother as it goes from one area to the next. But the angle of the bevel and the cutting edge is the same on the side as it is on the tip. Just the amount of cutting edge available to the wood is broader here and lesser over here. Let me show you, just for the fun of making more cuts, which is always fun to do. If I cut straight on, I'm going to rub the bevel, raise the handle until I get my cut, which is right about there. Now I know how smoothly I push makes a difference. If I go really fast, I get kind of a thread spiral. If I go slower, I get less of that. And if you see closely, you'll see even at my slowest pressures, there's little ripples in here because I'm using a very narrow radiused edge. Now, if I take this long side and what typically is referred to as shear cutting, it's all shear cutting actually. Let me do the same thing with the side of the tool. I'm only doing a part of it. And on the original cut, I can still see the ridges. When I use the longer portion of the bevel, I don't see those ridges anymore. Now, does this lead to a potential cut? Well, yeah, if you turn it too far and we no longer have bevel support. Let me see if I can make a catch here. So there's no cut, rolling in. There's the cut right there. No, I can't catch. Darn. I guess I'm just unwilling to do what has to be done to make it do bad stuff. But as I rolled it over farther, engaged more edge and less bevel, the cut quality is not near as good. In almost all cases, catches occur when the bevel is not touching the wood, either because it is not engaged fully or we've gone past the point of engagement. We want this hole flat against that wood if we can make that happen. If I turn it too far, it doesn't happen. Let me create a situation here for you to take a look at. Give me a second to just create a little bit of a groove in here. And all I'm doing is creating a really deep groove with, I know it's a bowl gouge. I'm preparing to illustrate a catch, a hole. Okay. If I take my bowl gouge and go down this side here, I can have bevel support. I come around here, and without turning the tool, the right edge is running into the ends of these end fibers here and could easily grab because I no longer have bevel support. Let's see if I can make that happen. Well, I don't want to make it happen. Let me see if I can make it. I'll go this way. There's my cut. Not very dramatic. And hardly anything to see, but let's try it again, one more time. Riding the bevel, riding the bevel, catch. Oh, beautiful. Let me shut the lathe off and leave the tool right where it is. This is why live center or safe drives help a lot. I was on the bevel until I came down and ran into this vertical wall. And the edge starts right here and starts digging in because there is no support behind that bevel. And I'm getting a different cut, different quality chip altogether. So just to illustrate, no bevel cut, no bevel support. Well, let's use a real shallow fluted gouge, which is appropriate for this kind of cutting. Let's do a quick bead, cove. Need just a little bit more pressure. I currently want to put more pressure against the wood than that setting allowed for. I'm just creating some space. And I'm going to make a bead out of this little bump right here. And the other side. Now I'm right at the spot where I'm ready to get a catch. I have been riding the bevel over the side, down here, and I'm beginning to flatten out on the bottom. All of a sudden, that lower edge is ready to run into that wall, and there is no bevel support for that cut. Not this direction. I know we're cutting against the flow of fibers, which we talk about a lot in class, but that's not the point I'm trying to make. To cut this, I need to go the other direction. Oh yeah, I'm right at the point where if I continue on up the other side, this edge is going to grab into fibers. Let's clean this up here because I don't like the look of it. So we know when we do codes, we go to the bottom where we have bevel support, in this case on the left side of the tool. And then I want to create support going down the other side, which will be support on the right-hand side of the tool. Oh, I got a catch. Wonder what happened there. Well, we just said the catches happen when there's no bevel support. So I started this cut here without that bevel being supported. I put the edge into the tool, into the wood. And it did this little spiraling thing. I didn't have the bevel behind the cutting edge. Now right now, there's bevel behind that cutting edge and it's going to be fine. But when I didn't have that bevel behind there, the edge engages. Because the tool was slightly turned this way, it wanted to create a spiral going that direction. If I turn it the other way, it wants to do a spiral that direction. That was another catch. You can see the marks from that thing. It's just terrible looking stuff. There's the catch here, coming out this way. So, catches and bevel support. Can I do that shearing cut with this tool like I just did with the roughing gouge a few minutes ago? Absolutely. Doesn't matter whether I'm going forward or backwards. I'm only concerned if the edge is being supported during the cut. So the difference between a pull cut and a push cut is simply which direction the tool is going. The engagement of the cutting edge and the bevel is still the same. Yeah, it could be here, could be here, could be here, but it's still the bevel and the cutting edge engaged together. Here's another gouge. Was a bowl gouge. It's been reground into what I call a bottom feeder. It's designed for being used on the inside of bowls. Long as that edge is engaged with bevel support, it'll cut. The only problem is the one exception to the things I was just telling you is these two corners. If the corners get too close to the wood, it can dig in. So that's the one exception. Can I do the bowl, the bottom feeder with this thing? Sure, it looks a lot like a roughing gouge to me. Does fine. Okay. I'm going to take this off the lathe and I'm going to put up a bowl and we'll take a look at the same set of rules and guidelines in a different scenario with things going, instead of fibers running this direction, but fibers running in this direction. So let me reset. I'll be back in a minute. Well, we've reset and I want to show you the same gouge issues as it relates to turning a bowl. So I've got a rough turn bowl here. I've got it between centers, but this would have been maybe on a screw chuck or faceplate initially. So one of the things we always talked about is the lack of use of this particular tool, the spindle roughing gouge, on a bowl. And the reason is, let me line it up here as best I can. fibers on most bowls are laid out this way. So as it turns around, we have side grain coming to the cutting edge, end grain, side grain again, and end grain. So it goes around and around. But every now and then we come up with this end grain situation. And if this tool engages that when it comes around, it'll grab underneath one of these fibers. And one of two things are going to happen. It's going to split that right out of the piece of wood, which is one possibility. The other possibility is if it's a nice solid piece of wood, that this tool, because it has such a narrow tang on the end of it, could very easily snap. So this is referred to as a spindle roughing gouge, not just roughing gouge. So I would never use it on the exterior of a bowl because of that particular situation. The biggest catch in our inventory is probably this. And trust me, I have seen many of these tools with either bent or broken, snapped off tangs on the tool. Can't do that. Can we use a shallow fluted gouge? Well, yeah, we probably could. The angles may not be quite what we want, but we could do that. But the difference is it doesn't have enough mechanical strength to be able to function efficiently against the bowl. So we stick with what we always refer to as a bowl gouge. And if I was going to be cutting on this piece of wood, and I will make a couple of cuts on it here, I'm going to go in a direction that I'm cutting across the sides of the fibers rather than into the end grain. I'm never going to make a cut directly into the piece of wood like this. That's very similar to what would happen with a spindle roughing gouge. So my cuts are always going to be from the tailstock toward the headstock when the bowl is in this orientation, thus cutting across the fibers, slicing across these fibers, rather than engaging even this tool in the ends of the fibers. So one of the cuts I don't want to make is this. Now the other thing I've seen a lot of happen, people will start off with the cut, get the bevel engaged, and everything's looking really good, and they just keep coming around like this and then pulling the tool. We've moved from a narrow cutting area to a larger cutting area, which means the depth of cut changes. But also many times that tool's brought around, but it's not rolled in such a way as to maintain the contact of the bevel against the wood. So as I said earlier in this video, when the bevel's not touching, a catch is likely to happen. Well, maybe not those words, but that's the point. So let me just make a cut so you can illustrate your point. If I lay the tool to the side and roll it open like this, I'm engaging that whole long edge. And that's a large cut. And this bowl is not running perfectly smooth right now. It's been sitting on my desk for weeks. So what I want to do is to minimize that cutting area. Force is down. Force is to keep that bevel against the wood. But there's a jump every now and then. So I'm keeping it on my hip to stabilize it, and down on the wood. And now that this is running true, I can increase the size of that cut. Can I cut from the rim back this direction while the bowl is in this position? Sure, I can, but I got to recognize what's going on. If I make this cut, I'm cutting against the flow of fibers. Remember, they're laying down like this, and when they're laying down like that, and I'm cutting across them. This works, but the biggest problem here of the catch is I'm going to go into this edge with an edge tool, and there's nothing behind this bevel supporting it. It is an unsupported cut, so I have to anchor to the tool rest and approach the wood very carefully. See, it's bouncing. And because it's bouncing, even more opportunity for it to contribute to a catch. So coming in for this edge here to try to true up the edge of that blank is a risky cut because I'm approaching the wood with a sharp edge and no bevel support. So let's turn it around and take a look at it on the inside. Okay, we've got it turned around. And the first thing I want to talk to you about is the problem of catching the tool on the edge. Now this is a roughed out bowl, so it's a wide edge. But I run into many times when a student or other wood turner will come in here and attempt to flatten or correct this edge. And because it's probably the least supported portion of this piece of wood, it is probably the most irregular at this moment. The other thing is that when I come in here to start this cut, I'm back to that unsupported edge again. Let me see if I can illustrate that better with a little larger gouge. If I come in here like this, my edge, I'm looking straight down, and I can see the edges against the wood, but there's maybe a 15 to 20 degree gap between me, between the bevel and the face of the wood. So I have an unsupported cut here. The only thing that's controlling how this edge engages is me and the tool rest. So I've got to be aware of that. So many times I instruct students to turn the tool over, and instead of cutting with the leading edge, to use this as a shearing cut or scraping cut and draw it across the edge in this manner. What that does is provide us with something that's less likely to catch. So if I was going to cut it like the way I said is dangerous, this edge is bouncy right now. I've got to anchor it to me tight. I've got to anchor it to the tool rest. And I have to be sure that I engage the least amount of edge I possibly can. As I look down to it here, I'm about maybe 5 or 6 degrees off of the center of the tool where there's very, very little tool to touch the wood. And rather than make a big cut, I'm going to just pass it over the high spots. So if you heard the popping sound, that was the fibers that were sticking up the farthest. So now let's make a second cut like that. And now right about here, I've got a little bevel support. Part of this bevel now is working against the wood. I actually do have bevel support. The risk is when I start right here, where that edge is against this edge, and that's a catch waiting to happen because most people don't have enough tool control to manage that. Let's go ahead and look at the interior cuts on this bowl. One of the things obviously is setting like this is if I make these cuts right now, I'm going to be projecting over the bottom of the tool rest far enough that I don't have really good support. So what I've got to do is to bring this edge in closer. I have to turn it inside the bowl, like that. And now as I come around this cut, I've got support on the tool as much as is possible. At this point right here, the tool sticking over the tool rest about 1 inch. As it gets towards the bottom, maybe 1/2 inch. At the top, maybe 1/2 inch. So also, the idea is how do I get the bevel engaged in this wood as early as possible? Because I want that bevel to be there so when the tool comes around and cuts. Now some people will push this tool all the way around, engaging the bevel in this area right here. Other people will start that cut and then roll the tool around so that we are engaging the longer edge. In other words, along here. So we start the cut here and rotate it. And now the edge of the tool, the long side, is engaged with the wood, giving you support. This is a good cut. It's a clean cut. But the difficulty is if I turn a little too far, I take the bevel up off of the surface of the wood, the edge engages and cuts much too deeply, in other words, a catch. So the difficulty with this shearing cut is the fact that we could roll the tool too far. So it's rough right now. I'm going to make that cut that I would prefer. starting out with not a lot of contact. You can hear the bouncing. So more pressure here, more stiffness here. And where do I start with this handle? I take the back of this bevel here, and I line that up with the outside edge of the bowl. That puts the handle where the handle needs to be. Otherwise, I'm sticking the edge in again with no bevel support. So let me show what that looks like again. I've got the tool back here. I can see that the edge is lined up with the outside of the bowl. I bring over to where I'm going to make the cut. I have pressure down on the tool rest. And I'm following the outside curve of the bowl around and finishing off that shape. Lined up, coming down. Now I can follow that same angle all the way around until I get down to a place in the bottom where I cannot get that bevel supported anymore. I'm going to run into the edge, and that's where I change to a different tool, one that's referred to as a bottom feeder. It has a steeper bevel, so I'm rubbing the bevel at this angle here. Or with the other tool, I would have been way over like this to try to get that same rub. It's a different tool and requires learning to use it. And here I'm still rubbing. And I can come across the bottom, a little out of round down there. But there's that bevel, it's contact. Now, what happens when you get down to that area is another thing. Here I'm cutting across the side of the fibers, and when I get down here, I'm actually going right into the end of the end grain. So I have to be, again, more cautious. And you can see you have a knot, a couple of knots in this piece, which causes even more interesting things to happen. So, catches with the gouges, solution, keep the bevel in touch with the surface of the wood. If you cannot, then you are risking the possibility of a catch, and it requires more pressure from you, both to hold the handle steady and to keep it in contact with the tool rest. And then as you advance, you really have to stay in charge. So I wanted to talk about those 2 points also. So next video portion of this series on catches, I'm going to talk about tools that have more than one edge, double-edged tools. That includes, first of all, you think the skew chisel, absolutely. But it also includes parting tools. And so we're going to talk about things that have 2 edges. Same things apply, but I've got a little bit more to share when we get into talking about those things. So come back for part 2 of this 3-part series on catches, what causes them, how I can minimize them. We'll see you in the next portion of the video series. Thanks for watching. Lined up, coming down.
Now I can follow that same angle all the way around until I get down to a place in the bottom where I cannot get that bevel supported anymore. I'm going to run into the edge, and that's where I change to a different tool, one that's referred to as a bottom feeder. It has a steeper bevel, so I'm rubbing the bevel at this angle here, where with the other tool I would have been way over like this to try to get that same rub. It's a different tool and it requires learning to use it. Here I'm still rubbing, and it can come across the bottom, a little out of round down there. But there's that bevel, it's contact. Now, what happens when you get down in that area is another thing. Here I'm cutting across the side of the fibers, and when I get down here, I'm actually going right into the end of the end grain. So I have to be, again, more cautious. And you see you have a knot, couple of knots in this piece, which causes even more interesting things to happen. So catch us with the gouges. Solution: keep the bevel in touch with the surface of the wood. If you cannot, then you are risking the possibility of a catch, and it requires more pressure from you, both to hold the handle steady and to keep it in contact with the tool rest. And then as you advance, you really have to stay in charge. So I wanted to talk about those 2 points also.